everyone. How are you doing? It's so awesome to be here with y'all for our third annual Women in ML Symposium. The agenda is packed and targeted for all experience levels. And I'm here to help kick things off to paint a better picture of what you're going to see today and how it ties back to all the incredible innovation that seems to have burst onto the scene over the last year in AI ML. My goal is to help you think about these new innovations and related AI ML tools that you might use to solve the biggest human needs that inspire you to build impactful solutions. And this is the key theme I really want you to think about today throughout all the sessions. To truly innovate, we need to always root our innovation back into the deep human needs we're solving. Great ML solutions start with strong design thinking. Who is your user? What are their needs? How will solving those needs impact their lives? Right now is an incredibly exciting time for machine learning, whether you're just getting started or a seasoned practitioner. The pace of innovation over the last year has been dizzying, and it's only picking up. Large model integrations and applications have exploded across larger companies, startups, and right here at Google. And we've not only seen the emergence of increasingly large language models, but deeper integration of both LMs and smaller models across an incredible range of products. Fundamentally, large models have opened up a number of new use cases people simply hadn't thought possible before. In just the last year, we've launched products powered by large models like Bard and Duet AI, your AI-powered collaborator, available across Google Cloud, including Workspace, and IDEs, integrated development environments, to help you get more done faster. And we've continued to make incredible advancements, from no-low-code offerings to those for more advanced practitioners. This includes consumer features you already know and love, such as real-time editing features in photos, incredible effects in Meet, AR features in shopping, real-time translation, and dubbing or music generation in YouTube, and in our developer products like Vertex AI, Kaggle, Visual Blocks, our visual programming framework, and Keras 3.0, which is a complete rewrite of the Keras APIs, which lets you run your workflows on top of either JAX, TensorFlow, or PyTorch frameworks, unlocking brand new large-scale model training and deployment capabilities and enabling multi-framework machine learning. We leaned into making sure that our ML works great on your devices, so you always have that little bit of magic in your pocket, on your wrist, in your ears, and more. And of yesterday, Gemini. Gemini marks the next phase on our journey to making AI more helpful for everyone. Gemini is the most capable and general model we've ever built and is the result of large-scale collaborative effort by teams across Google, including Google DeepMind and Google Research. It's the largest science and engineering project we've ever undertaken. Gemini was built from the ground up to be multimodal, which means it can generalize and seamlessly understand, operate across, and combine different types of information, including text, code, audio, images, and video. And Gemini is our most flexible model yet, able to efficiently run on everything from data centers to mobile devices. Its state-of-the-art capabilities will significantly enhance the way developers and enterprise customers build and scale with AI. We've optimized Gemini 1.0, our first version of the model, for 3 different sizes. Gemini Ultra, our most capable and largest model for highly complex tasks. Gemini Pro, our best model for scaling across a wide range of tasks. And Gemini Nano for mobile devices. And while I love all ML, I'm especially passionate about devices, which is why I'm so excited and proud of my team and their support for Gemini Nano, which is optimized for mobile, bringing the power of large models with you anywhere, anytime. Gemini Nano is our most efficient model built for on-device tasks, opening support for a range of important use cases. Running on device enables features where the data should not leave the device, such as suggesting replies to messages in an end-to-end encrypted messaging app. It also enables consistent experiences with deterministic latency, so features are always available, even when there's no network. And Gemini Nano is distilled down from the larger Gemini models and specifically optimized to run on mobile silicon accelerators. It enables powerful capabilities such as high-quality text summarization, contextual smart replies, and advanced proofreading and grammar correction, just to get us started. And supporting Gemini Nano is Android AI Core, a new system service in Android 14 that provides easy access to Gemini Nano. AI Core handles model management, runtime, safety features, and more, simplifying the work for you to incorporate AI into your apps. Now, many of you are tuned in today and many new to machine learning because of large language models. So I want to walk you through a super short overview. LMs, large models, specifically generative AI, have fundamentally changed technology in the last year plus. And it's not just the tech, but the ease of access, natural conversational style, and many popular applications, and several other underlying factors that have made LMs to seemingly burst onto the scene. Whatever the underlying magic, this shift has helped quickly unlock solving big human problems, and in a variety of ways many of us hadn't yet thought of, ranging from summarizing notes on a work call, reducing work housework, to inspiring creative flow with techniques in generative music. And even if large models don't solve everything, and the majority of our critical ML solutions are still running with traditional ML, it's important to understand all of the underlying advancements that have helped make large models possible. Because at the end of the day, it's all machine learning inspired by deep human needs. All right, let's dig in. So, at first, traditional programming consisted of providing a specific set of instructions for a computer to execute. You had to know precisely which sequence of actions to follow to get from input to output. So you could teach the computer something like cat. What type of it? Is it an animal? How many legs does it have? 4. Ears? 2. Fur? Usually. Likes? Yarn, catnip, naps, and of course, ultimate power. Then neural networks came in around 2012, and we trained AI with a bunch of data, just piles of animal pictures, teaching the AI which ones were pictures of cats versus other animals, aka not a cat. And after a certain amount of training, the AI became able to recognize cat pictures with great quality. The model is a single task model trained to solve a specific problem. So, cat or not, hot dog or not. Then, this evolved into large language models, or LLMs, which ML algorithms that can recognize, predict, and generate human languages. LLMs are normally pre-trained for multiple tasks on a large corpus of text, followed by fine-tuning on a specific task. Think terabyte scale, resulting in large models with tens to hundreds of billions of parameters, which are the weights the model learned during training, used to predict the next token in the sequence. And large language models introduced a brand new paradigm. It's a bit like if you had the whole encyclopedia and you hand it to a child and asked them a variety of questions across multiple domains, like, so you learned a lot about cats and other concepts like hot dogs and boxes and yarns and naps and trees and birds. So what's a cat? And then they can give you a pretty good idea of what a cat looks like. LLMs can also be called large models, or I've abbreviated LMs, which includes all types of data modality, and generative AI, a model that produces content. For Gen AI, computers not only learn from examples, but can also use those examples to create or generate new outputs. It works by feeding a large data set of text, images, or other data into an AI model. That model learns to identify patterns in the data, using those patterns to generate new content, which is similar to what it was trained on. Now, when you look behind the scenes, you can see that this technology has actually been gaining momentum for years. For the purposes of this talk, I'm going to zoom past a bunch of stuff to 2017 with the introduction of transformers, an architecture designed around the idea of attention. This architecture made it possible to process longer sequences by focusing on the most important part of the input, solving memory issues encountered in earlier models. Taking us back to that human element of everyday life, you can imagine that this state-of-the-art architecture can also be incredibly useful at solving everyday problems, like translation, or BERT, which emerged in 2018 to make search even better, or AlphaFold, developed by our DeepMind team, which allows access to over 200 million protein structure predictions to accelerate scientific research. Practically, some researchers may take a few years to be able to map a single protein. And innovations like this have drastically accelerated their ability to expedite key experimental work to unlock innovation in advancing areas like human health. And more impactful models have emerged quickly, one after another, many powering incredible products here at Google, from T5 to Lambda to MUM to Palm and Palm 2 and to Gemini. our newest model. Now, when we're thinking about LMs, it's not just about a single architecture. There are multiple factors, including right timing, at play here. There are a number of underlying advancements across machine learning software, hardware, and the humans behind both that have led to the rapid acceleration that have helped large models make ML in general more accessible to almost anyone, regardless of your technical background. And that's how we really thought about all the sessions that we have for you today. Each speaker will walk you through different areas that make both traditional and generative AI a reality. Okay, so when we think about advancements beyond architecture that have led to the explosion in usage and application of generative AI, I like to think about it in 4 key areas: computational power, machine learning techniques, training data, and access to innovation. One of the most important things that you should understand at a high level is the key infrastructure that a machine learning actually runs on. Specifically, when you're trying to crunch a very, very large amount of data, you need a whole lot of computing power. Computing resources have become more powerful, such as with graphics processing units, GPUs, and our tensor processing units, TPUs, first launched in 2015, which lets you do complicated processing much faster than traditional processing units. And you may have noticed that alongside our Gemini announcements yesterday, we unveiled our new TPU V5P, our most powerful, scalable, and flexible AI accelerator thus far. And the AI hypercomputer from Google Cloud, which is a groundbreaking supercomputer architecture that employs an integrated system of performance-optimized hardware, open software, leading ML frameworks, and flexible consumption models. You can check out the talk later on Cloud TPUs by Nithya if you want a deeper dive. But the key takeaway for you here is it takes a lot of power to run large models and even more to train and crunch all of the vast amount of data required to get to them to the point where they're ready for primetime consumption. And data is really what's key to everything. Without data, we know the models simply can't learn. As we get better at collecting and analyzing large amounts of data, be it structured data or unstructured data like audio or video files, the model performance can improve dramatically. But for you, as you develop, figuring out what type of data your customers need or have gets complicated quickly. Do you just need better text to better understand and generate natural written language? Or what about when it becomes dialogue and spoken conversations? Or when you need to communicate with computers through code? Or maybe you need image and audio. Now, I want to pause to also call out that with more data comes more responsibility. And you can dig into that with several of our talks, including one coming up shortly from Minu on the importance of data-centric AI. Now, in the last several years, significant advancements in techniques used to train these models have also helped lead to large leaps in performance. We've covered more power means more data crunching and ability to handle more diverse data types, both structured and unstructured. But it's not just about training on more data. Also, the ability to do it faster means we can have tighter feedback loops, meaning we have the ability to more rapidly incorporate higher and higher judgment evaluations of that model performance. Specifically, techniques like reinforcement learning with human feedback has been critical as models are learning from vast amounts of data, of unstructured data like images, video, and audio, which require much higher judgment in knowing how to evaluate outcomes. Computers trained in traditional ML would only be able to handle simpler questions like, is this a hot dog? Yes or no. But with faster iterations of humans providing real-time feedback, we can get more nuanced expert opinions to help guide models to better judgment, like determining which corgi is the cutest, most dramatic, and corgi-tastic. You can learn more about techniques and good design first principles from Oveta on the panel later. Now, with increased availability of open source models of all sizes on platforms like Kaggle and Hugging Face, and open source frameworks like TensorFlow, JAX, Keras, and PyTorch, more and more developers have been able to learn more quickly from each other, innovating faster on the models themselves, the data techniques, and fine-tuning for a wide variety of use cases, solving deep customer needs. This innovation and overall community expertise has been critical in supporting the acceleration of large models and ML in general. And easier access also comes through no-code platforms like LM chat interfaces like Bard and ChatGPT, which dramatically open up access to everyday customers to start using and being inspired by LMs without needing to know how to code. It's made it as simple as typing whatever you're thinking in whatever language you think in to be able to interact with large models. This meant that large models were previously only available to researchers with deep technical expertise and access to large amounts of compute were now available to almost anyone. And if you want to learn a little bit more about increased access and our OSS offerings, we've got a bunch of talks coming up. Check out Andrada's talk on Kaggle, Eve's talk on OSS, and Divya's talk on Keras coming up. Now, because it's so much easier to access large models and build with, we've seen a rapid integration of LMs in applications focused on solving a diverse set of customer problems across a variety of tasks critical to most of our lives, ranging from assistance, coding, translation, summarization, generation, and more. This means that the ML running behind the scenes is super simple and more approachable for people. And this means it made it as simple as typing whatever you're thinking or trying to do in whatever language you're thinking in to be able to interact, and has opened up a variety of applications. Now, if you want to learn more about creating practical applications, you can check out Na's talk on visual blocks, our visual programming framework, Kelly's presentation on autonomous agents, or Yvonne's presentation on generative AI using Google Cloud. And adding to this, there's a proliferation of smart devices over the last decade that means that customers are now used to having devices like phones, wearables, IoT with them almost anytime, anywhere in the world. This popularity has been, in part, powered by increased advancements in device machine learning, including critical techniques around model optimization and quantization, often baked into frameworks like TF-Lite or MediaPipe, which means that customers are more used to and demand smarter and smarter applications on all of these devices that they have with them all the time. This means that they have more potential needs and use cases that large models have the potential to solve than ever before. Now, if you want to learn more about deploying machine learning models to mobile devices, make sure to check out Zoe's talk. With all of these factors and all of this potential, this brings diverse responsibility as you look to build. As we get better at collecting and analyzing large amounts of data, think about how these practical applications can be centered around key human needs, and how can you be more responsible? You will run into a diverse set of opportunities to develop responsibly, each with their own nuance. And many of the answers to what responsible means are still being weighed, so it's critical for you to keep educating yourself, staying informed on the latest guidelines, and always asking if it's good enough. To join part of that conversation, check out the panel on the impact of generative AI in different industries with Joanna and several other guests later today. All right, now quickly back to Gemini, as I'm getting you off dreaming a little more about what you can build. This is a significant milestone in the development of AI and the start of a new era for us at Google as we continue to rapidly innovate and responsibly advance the capabilities of our models. We have made great progress on Gemini so far, and we're working hard to further extend its capabilities for future versions, including advances in planning and memory and increasing the context window for processing more information to get better responses. We're so excited by the amazing possibilities of a world responsibly empowered by AI and a future of innovation that will enhance creativity, extend knowledge, advance science, and transform the way billions of people live and work around the world. Okay, before I hand you off to Eve, I have one more thing to ask. What are the deep human needs that inspire you? Tell me what inspires you. Go ahead, take a second, grab a piece of paper, pen, pencil, write it down. Go wild. Think about the most important problems that create value. How might you use AI/ML to help us find a safer path to Mars, solve what's for dinner, or bring a little more fun into your daily life? Imagine a world of possibility where you can make a rainy day just a little bit brighter. Now that you're all inspired, Let's dig into better understanding some of the key advancements driving AI ML innovation around open source and frameworks that help us build better models and put a little extra magic into your everyday lives right in your pocket.